Question number 81. Among the given options, the correct order of decreasing reactivity of the compounds towards electrophilic reagent is. It means we are talking about the reaction in which electrophile is the attacking reagent, and we have the compounds which are phenol, anisole and chlorobenzene. It means aromatic compounds these are. We are comparing phenol, then anisole, structure is here OCH3, and after that there would be the turn for chlorobenzene. All three are organic compound. Further, if I talk about the next option, benzene we have, further phenol this way, and after that there is chlorobenzene this way. Further, next one is toluene. This is toluene, then nitrobenzene, and after that there is simply benzene. And in the fourth option we have cumene. I'm just drawing here the structure of cumene this way. This is cumene. After cumene, the next one is toluene, you know that. And then there's a turn for benzene. Now we have to arrange them in the correct order of decreasing reactivity towards an electrophile. It means we are talking about electrophilic substitution reaction. If we talk about phenol, we have this OH group here. This is electron releasing group plus our group it is, and this increases the reactivity towards electrophilic substitution reaction. So in this case it is increasing the reactivity. It means it is most reactive. Further, if I talk about OCH3, in this case presence of this CH3 is reducing its reactivity towards electrophilic aromatic substitution. Further, there will be the turn for the chlorobenzene. So first is correctly given. After that, if I talk about the next one, benzene is written here as the most reactive compound towards electrophilic reagent. So this is wrong. That's why I'll just mark a cross here without checking further. Now, third one, toluene we have. The structure is given here, then nitrobenzene, and after that here is benzene. If I talk about nitrobenzene, this nitro group is deactivating group. It will not increase reactivity towards electrophilic substitution. It reduces the reactivity. It does not increase the reactivity towards electrophilic substitution while it decreases. It is deactivating group. That's why benzene should be before nitrobenzene. So in this case, third one is also wrong. In case of option 4, this toluene should be here before cumene, because the toluene shows more hyperconjugative effect, and that is why only one option is correct here, the first one. Now, after that, question number 82 we have. In the reaction, we have the reaction in which propyne is given. It is treated with NaNH2 in liquid ammonia, followed by the reaction with bromoethane. After that, the product A is formed. Further, it is treated with hydrogen in the presence of palladium and carbon in the presence of BaSO4 to give you B. You need to identify A and B. In this case, if I talk about the first process, CH3C triple bond CH, propyne we have. When you treat it with NaNH2 in liquid ammonia, it is showing its acidic nature. There would be the formation of CNA. This type of compound is formed. Sodium propionide, you can say. Now, it's further treated with CH3CH2Br. In this case, the product is resulting in chain enhancement CH2 CH3. This would be the product. Now what you are doing now, we're just going to treat this A. This is now A with hydrogen. Hydrogenation you are going to do palladium and carbon followed by barium sulfate. So here is the formation of the product, that is, this is controlled hydrogenation, and that results in the formation of cis product. This is B. Now, after this, it is the turn to identify A. If we talk about the name of A, this is pent 2-ine. That's why A is pent 2-ine. Where is it is given? It is given here in option 4. Let's check. The product B also, this is cis pent 2-ene. If you look at the structure, this is cis pent 2-ene. That's why option 4 becomes your correct option, in which both the compounds are given correctly. After that, here is the turn for question number 83. Select the incorrect statement among the following. Photochemical smog are oxidizing agents. It means if I talk about photochemical smog, that is acting as an oxidizing agent because it contains oxidizing substances like peroxyacetyl nitrate, it contains oxides of nitrogen, ozone, etc. That is why photochemical smog is also called oxidizing smog, and this statement is correct. Further, clean water would have a BOD value less than 5 ppm. This is also correct. Biochemical oxygen demand of pure water should be less than 5 parts per million. That's why it's correct. After that, third option. During formation of classical smog, the level of oxygen in the atmosphere goes down. This is an incorrect statement. I'll just mark a cross here. After that, ozone depletion potential is maximum in CFCs. Yes, we know that chlorofluorocarbons are the most effective reasons for ozone layer depletion. So, this is also correct. So, only one statement is incorrect. That's given here as option 3. Now, question number 84 we have. If the freezing point of 0.1 molar solution of X in water is more than 0.1 molar solution of Y in water, then which among the following conclusion can be drawn? We know that depression in freezing point is a colligative property, and its value can be affected by the change in the number of the solute particle in the particular solution. So if we talk about the decrease in freezing point in water in case of Y, it's clearly showing you that there is the number of particle which is more. And how these particles are more? Because Y is undergoing dissociation. But if I talk about X, there is no dissociation. That is why it is so. So simply let's check the options given here. X is undergoing dissociation but not Y. This is wrong. Y is undergoing dissociation but not X. Yes, it is correctly given here. That's why it becomes correct. Both X and Y do not dissociate or associate. This is wrong. And further, molecular mass of X is smaller than molecular mass of Y. You cannot interpret this fourth option from this. So only second statement is there, that is the actual conclusion that you can draw from the given thing. So option 2 becomes your correct answer. Question number 85. The heating of benzyl methyl ether with HI produces majorly. We are talking about an ether that is benzyl methyl ether, this way. HI is added. In this reaction, there is SN1 mechanism due to the presence of this bulky group of benzyl group, and now there's the formation of two products. One is benzyl iodide. Along with that, methanol would be formed. In this case, we have obtained two products where these products are given. If you look at the given options, you will see that these two products, benzyl iodide and methanol, that is given in option 1. So, this is your correct answer. Option 1. After that,